GenAI and MLOps Part 5. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. ML monitoring, Mach 50 focus, model drift, explain data drift, concept drift, prediction drift, and how you would monitor and respond to each in production. Here's a strong way to approach it. Data drift is a change in input feature distribution. Concept drift is a change in the relationship between inputs and target, so old patterns no longer predict outcomes. Prediction drift is a change in model output distribution. Monitor feature distributions, schema, missing values, embedding distribution, prediction distribution, delayed ground truth metrics, and business KPIs. Respond based on impact. Investigate data pipeline changes. Compare against seasonality. Retrain with fresh data. Roll back feature or model changes, or adjust thresholds. Do not retrain automatically on every drift alert without validation. Nice. Let's continue. Question 2. ML deployment, Mach 50 focus, model deployment strategy. How would you deploy a new ML model safely using Canary, Shadow, A or B testing, rollback, and champion challenger patterns? Here's a strong way to approach it. Use shadow deployment when you want the new model to receive live inputs without affecting users. Use Canary to send a small percentage of traffic and watch latency, errors, model metrics, and business KPIs. Use A or B testing to compare business outcomes between model versions. Use champion challenger when a candidate must beat the current production model before promotion. Keep rollback simple by retaining prior model artifacts and routing config. For ML, rollback criteria must include business and quality metrics, not only infrastructure health. Great. Moving on. Question 3. ML incident, Mach 50 focus, bad model incident. A model is technically healthy but business KPI suddenly drop after release. How would you investigate and mitigate? Here's a strong way to approach it. Open an incident and check the release timeline, model version, feature version, traffic split, customer segments, and business metric drop. Compare old versus new predictions, input distributions, confidence scores, feature freshness, training serving skew, and any upstream data changes. If the drop aligns with the model release, pause rollout or roll back to the previous champion while investigation continues. Preserve evidence, model version, data sample, metrics, and traces. After mitigation, update evaluation gates so the missed business failure becomes a pre-production or canary check. Alright, next question. Question 4. ML platform, Mach 50 focus, ML platform design. What shared platform capabilities would you build for data scientists and ML engineers to ship models safely and repeatedly? Here's a strong way to approach it. Build shared capabilities across the life cycle. Data access patterns, data validation, feature store or reusable feature pipelines, experiment tracking, model registry, pipeline orchestration, CI or CD or CT, containerized training, model serving, monitoring, drift detection, approval workflows, rollback, security, and cost visibility. The platform should provide golden paths so teams do not reinvent infrastructure, but still allow flexibility for different model types. Strong platform answers include reproducibility, lineage, tenant isolation, least privilege, observability, and self-service developer experience. Let's keep going. Question 5. Scenario or system design. Scenario. Your Python API suddenly receives 10 times traffic after a product launch. How would you redesign the system for scale and reliability? Here's a strong way to approach it. First, stabilize. Check error rate, latency, CPU or memory, DB pool saturation, queue depth, and autoscaling. Add horizontal replicas. Tune unicorn or unicorn workers. Increase database pool carefully, and enable caching for hot reads. Then redesign for sustained load. Stateless API behind a load balancer. Redis cache. Async workers for slow tasks. Rate limits. Back pressure. Read replicas if needed. Auto-scaling based on real metrics. And slow-based alerts. On to the next one. Question 6. Scenario or database. Scenario. A PostgreSQL-backed Python application has slow searches and frequent lock waits. How would you investigate and redesign it? Here's a strong way to approach it. Inspect slow query logs, pgstat activity, pgstat statements, explain plans, lock waits, missing indexes, n+1 ORM queries, and transaction duration, short term, add or fix indexes, reduce transaction scope, paginate queries, and kill or avoid runaway queries. Long term, redesign search with proper full text indexes or a search engine, separate read or write paths, use background jobs for heavy updates, and make migration safer with online patterns. Good. Here's another one. Question 7. Scenario or caching. Scenario. A dashboard endpoint is slow because it recalculates expensive reports on every request. How would you design caching and background refresh? Here's a strong way to approach it. Move expensive calculation out of the request path. Use a scheduled worker or event-driven job to pre-compute report snapshots. Store them in PostgreSQL or Redis, and serve the dashboard from cached data. Add TTLs, versioned cache keys, invalidation on relevant data changes, and a stale while revalidate pattern if freshness can be slightly delayed. Monitor cache hit rate, refresh failures, data age, and report generation latency. Nice. Let's continue. Question 8. Scenario or queues. Scenario. Users upload large files and the API times out while processing them. How would you redesign the upload and processing flow? Here's a strong way to approach it. Use signed URLs so users upload directly to object storage instead of sending large files through the API. The API creates metadata and returns an upload target, then a storage event or explicit finalize call enqueue processing. Workers validate, scan, parse, transform, and update status asynchronously. The frontend pulls or subscribes for status, add file size or type limits, retries, dead letter queues, virus scanning, encryption, and per-user access checks. Great. Moving on. Question 9. Scenario or DevOps. Scenario. A full-stack Python app has manual deployments and frequent production regressions. How would you design the CI or CD and release process? Here's a strong way to approach it. Create a pipeline that runs linting, formatting, unit tests, integration tests, front-end tests, security scans, image builds, and migration checks on pull requests. On merge, build immutable artifacts, deploy to staging, run smoke tests, then promote the same artifacts to production with approval and progressive rollout. Add feature flags, rollback, deployment markers, database migration safety, release notes, and production monitoring gates. Alright, next question. Question 10. Scenario or Kubernetes. Scenario. Your Kubernetes deployment has intermittent 502 errors during rolling updates. How would you debug and fix the rollout design? Here's a strong way to approach it. Check ingress or load balancer backend health, pod readiness, termination logs, pre-stop hooks, graceful shutdown, readiness probe behavior, and whether traffic reaches pods before they are ready or after shutdown starts. Fix with correct readiness probes, startup probes for slow apps, pre-stop delay, termination grace period seconds, connection draining, max unavailable 0 or low, sufficient replicas, pod disruption budget, and backward compatible releases. Let's keep going. Question 11. Scenario or observability. Scenario. Customers report errors, but logs are hard to correlate across front-end, back-end, workers, and database calls. How would you redesign observability? Here's a strong way to approach it. Introduce a correlation or request ID generated at the edge or front-end and propagate it through API calls, worker jobs, logs, traces, and downstream requests. Use structured JSON logs with service, env, version, user or tenant context where safe, and error codes. Add open telemetry tracing across frontend or backend or DB or external calls. Metrics for golden signals. Dashboards by user journey, and alert runbooks that link to traces and logs. On to the next one. Question 12. Scenario or security. Scenario. A multi-tenant SaaS app accidentally exposes one customer's data to another customer. How would you respond and redesign tenant isolation? Here's a strong way to approach it. First, contain the incident. Disable the affected path. Preserve logs. Identify impacted tenants or data. Notify stakeholders. And rotate credentials if needed. Redesign by enforcing tenant ID at the data model and query layer. Adding authorization checks server-side. Using raw-level security where appropriate. And preventing tenant IDs from being trusted from the client. Add tests for cross-tenant access. Audit logs. Scoped caches. And security review for every data access pattern. Good. Here's another one. Question 13. Scenario or frontend? Scenario. The frontend feels slow even though backend latency looks healthy. How would you investigate and improve end-user performance? Here's a strong way to approach it. Measure real user metrics. LCP, INP, CLS, JS bundle size, API waterfall, browser errors, CDN or cache behavior, and client rendering time. Backend latency may be fine while frontend is blocked by large bundles, sequential API calls, slow hydration, inefficient rendering, or poor caching. Improve with code splitting, CDN caching, image optimization, fewer round trips, optimistic UI where safe, pagination or virtualization, and frontend monitoring. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.